All right, algebra students, today it is word problem time for rational equations. In this video, we are going to look at two types of word problems for rational equations. The first one are going to be what we call work problems, and it's when we have two people or two items doing work on the same job and it's taking them different amounts of time and trying to determine how much time is it going to take if they did it together. And the second are distance equals rate times time problems and how we can apply that into the rational equation bank that we are working in right now. So the first thing is for work problems, how we set these up is 1 over the first person's time it takes to complete a project plus 1 over the amount of time it takes the second person to complete the project is going to be equal to 1 over the total time it would take if they did that together. Now, the numerator is not always 1 here. It is representing the number of jobs that need to be completed. So if we talk about and we look at our examples here, in the first example, a carpenter can build a desk. Well, it's one desk, so the numerator would be 1. In our second one, we have a fountain with 2 drain valves. If the first drain is the only one that's open, it drains completely in 4 hours. The job is draining completely. Well, it's not going to do that more than one time, so the numerator is 1. However, in our third example here, it talks about a pen factory has 2 machines that are making pens, and together the machines make 1,500 pens. Well, the job is making a pen, so in this case, that machine is doing this job 1,500 times in 8 hours. So your numerator, the number of jobs completed for that third example there, is going to be 1,500 pens. Okay? And you'll get an opportunity to check answers on that here momentarily. So again, following this pattern, we have a carpenter building a desk in 6 hours, another carpenter, same desk, 8 hours, different amounts of time. One works faster than the other. We can make a prediction or a calculation on how long it would take if they were working together on one desk. So in this case, the first person completes one desk in 6 hours. Okay. Number of jobs completed was 1, total time was 6 hours, plus the second person, one desk in 8 hours. It's going to be equal to one desk for them together, but how many hours? This is what we've been working on with LT31 previously. We are going to solve a rational equation. In this case, we talked about finding the least common denominator. And we also talked about how it's okay if you just find a common denominator. It's just going to make things a little bit easier if you find the least common denominator. So in this case, some of you might just recognize, okay, I'm going to use a common denominator and multiply all 3 denominators. That's okay. And that means what you're doing is you're going to multiply every term by x, by 6, and by 8 in every single term. X times 6 times 8 and x times 6 times 8. And that's when you're looking to reduce each term. But reduce this term on the left, the fraction on the left, 6 in the denominator, 6 in the numerator. That leaves me with 8x plus 8 in the denominator, 8 in the numerator. That leaves me with 6x. And that's equal to, in this ratio, the x's reduce, and it leaves me with 48. Okay. I trust that we can do the algebra here, okay, that we get 14x equals 48. We wind up with x is equal to approximately 3.4. Okay. We're going to round that to the nearest tenth. And when it's asking our initial or our final question is, how long will it take to build the desks together? 3.4 is representing the denominator. That's the total time. It's going to take about 3.4 hours. So we want to answer a word problem with a word answer and stop there. Okay. What I want you guys to do is go ahead, press pause, and try this next example here. unpause when you're done. Here we're just checking if our setup is correct. After finding our common denominator that we multiply every term by, we get here. And we wind up with about 2.3 hours for this fountain to drain when both valves are open completely. So in our next example, this is when we were talking about, or I was talking about, how our work problem equation that we had up at the top here, it's not going to have a numerator of 1 because we're not talking about completing just one thing, one desk, or draining one pool. We're talking about making 1,500 pens. Okay? Beyond that, what we don't know is different. Okay? In this particular problem, I know that the machines together make 1,500 pens in 8 hours. So we have 1,500 pens in 8 hours. The number of jobs completed was 1,500. The total time was 8 hours. Now, machine A, this is where things might get tricky. You got to pay attention here. Okay? Machine A makes pens 2.5 times faster than machine B. So we're still talking about making 1,500 pens. So for both machine A and machine B, we're talking about a numerator of 1,500. It's the denominator that we don't know. I know that in machine A, they are faster. So I might say that they complete the job in, I don't know, T hours. But since they're faster, I'm going to take machine B and make that 2.5 T hours. Now, a common misconception here is to make it 2.5 T for machine A, but that would mean that the amount of time is bigger in machine A, and it should be smaller because that's faster. So when I come up with my ratios here, it's 1,500 over T hours, and for machine B, it's 1,500 over 2.5 T hours. Okay. Before we go through and solve, why don't you go ahead and hit pause, read through this second try problem on the bottom here, and see if you can just set up your ratios before you solve anything. So here's how our setup should be. Again, my numerator now is 100 because that's the number of pieces of paper that are being copied. Denominators together is 10 because it takes 10 seconds together. I'm going to have T as far as the amount of time for copier X and 1.5 T for copier Y because copier X is faster. So that's going to be the less amount of time. Okay. Again, press pause, and what I want you to do is try to solve the example problem about the pen factory. Unpause to check that answer, then pause again to check your answer for the copy machine problem. So hopefully in this example you got to 11.2T, but make sure that you answer the full question. It's asking us here to find out how many hours machine A would need to make 1,500 pens by itself. Since we said machine A was T hours, getting this answer means machine A will take 11.2 hours. For machine B then, I have 2.5 times the 11.2. That means machine B will take about 28 hours. Okay. Keep that in mind as you go ahead and pause to try that last problem on this page. So for this try problem here, it should take machine X about 16.6 repeating, or 16 2/3 seconds, to make those 100 copies, and machine Y 25 seconds. Go ahead and check your work, make sure it all makes sense here. If you need to pause and go back and rewrite stuff, please do so. And then the last example I want to work through is on the back of this page. It's the first problem that we're going to talk about, distance rate, and time. Okay, so the equation states that our distance we travel is equal to the rate or the speed with which we are traveling and multiplied by the amount of time that we are traveling. In this case, we're going to be talking about two different items or people or things that are doing the traveling. In this first example, we can travel 40 miles on our motorbike in the same amount of time. That's an important statement here. In the same time that it takes our friend to travel 15 miles on their motorbike. But the friend is obviously riding slower, in this case 20 miles per hour slower than you. What we don't know is the actual speed of each bike. And we can use our distance, rate, and time equation to kind of help us. I'm going to recommend that you kind of set up a table that's going to help you do that. So your table would look something like this, where we're going to have you and your distance, you and your rate, you and your time, your friend's distance, your friend's rate, and your friend's time. And what's going to be interesting here is we're talking about the same amount of time, but we don't know how much time that is. When we don't know how much time or we don't know something, we apply a variable to that. So I'm going to, again, recommend that we use t for time, but we know that you and your friend are using the same amount of time. So your time is t, your friend's time is also exactly t. And since that time is equal, I know that the time for you must be equal to the time for your friend. That's an important step to recognize before we put any of the other values or variables in here. Okay. Now, the other thing that we want to talk about is this equation here. That's solved for D. I might ask you to solve that equation for T though, or solve it for R. If I were to solve that equation for T, algebraically, I'm dividing both sides by R. I get D divided by R is equal to T. That's really important. Okay. Now we fill in the rest of our table with the information we know from our word problem. Okay, we know that you travel 40 miles. So you and distance is 40 miles. We know that your friend is traveling 15 miles. Now we don't know your rate. We don't know your friend's rate, but we do know that your friend has a bike that is 20 miles per hour slower than yours. So let's think that one through. Let's say you ride at 30 miles an hour, your friend is riding at 20 miles an hour. If you ride at 50, your friend is at 30. It's always whatever you are minus 20. Okay? So if I said that you are traveling at a rate of R, your friend must be at a rate of R minus 20. Okay? So I'm going to give you a second here to let that sink in. I have enough to set up equations either in D equals RT, but most importantly in T equals D over R. Okay? So I know that the time for you is going to be equal to your distance, which was 40 miles, divided by your time, or your rate, which is R. I know that for your friend, their time is going to be equal to 15 divided by their rate, which was R minus 20. And as we mentioned earlier, your time and their time are the same. So I can set those two ratios equal. And what we have now is a proportion, okay? Just like the first few problems we started solving in this learning target. Okay? Go ahead and take a second and see if you can solve that proportion. So we should find that R is equal to 32, which means your bike speed, which is R, was 32 miles per hour, and your friend's bike was 20 less than that, 12 miles per hour. Okay. What I want you guys to do is press pause and try the next two problems on here. You will have an answer key provided to you to check your work. Your answers and work.